I recently presented a demo on API resiliency testing at the API Days Australia. We all know resiliency matters, but we often underestimate how fragile our digital world is. Let me start with a few recent incidents. We all remember the CloudStrike outage. Flights couldn't take off, nurses couldn't access patient medication charts, critical government services went dark. The sheer snowball effect shocked everyone. You would think that after such a global incident, we couldn't see another similar meltdown anytime soon. Well, you might be wrong. In June 2025, Google had a major outage caused by something as trivial as a null pointer exception in their service control system, and it impacted even more companies than CloudStrike outage. If you look at this graph, you would see the number of affected organizations is almost double. And that wasn't all. On 12th September 2025, Cloudflare accidentally ended up DDoSing its own infrastructure. Their tenant service was hammered endlessly because a piece of React code triggered infinite retries on an API call. One faulty call overwhelmed an entire service, took their dashboard offline, and caused a 3-hour outage. Then, exactly 2 months later, 12th November, Cloudflare had yet another massive outage, and this time the impact was so severe that the company lost 2.83% of its stock value in a single day. And one more example, a bit older but unforgettable. A Tesla API outage that locked owners out of their own cars. Imagine not being able to enter your own vehicle during an emergency simply because an API failed. APIs have become a fundamental fabric to our entire digital ecosystem. These examples highlight a painful truth. When an API goes down, everything that sits on top of it comes crashing down. So it is our responsibility to ensure that APIs we build are resilient, predictable, and can withstand a variety of adverse conditions. How do we test the resiliency of an API? There are actually an entire spectrum of tests that we can perform to ensure your APIs are resilient. We could start with something as basic as negative functional testing, where you can do boundary value analysis, invalid data types. You are looking for things like overflow, underflow conditions, and so forth. But that's not enough. Your services rarely work alone. It depends on other services, and those APIs do change. So we need to test what happens when the services don't respond back in time. Check if they are contract compliant, whether the changes made to those services are backward compatible, and if not, how does your service behave? Furthermore, you can expand into a whole class of chaos engineering, fault injection, failover, and other kinds of interesting testing. And then you can turn a notch up by moving into performance testing, where you can do load and stress testing. But my favorite is soak testing, where you leave the system running for a long duration and see if memory, CPU, or any other resources usage goes up gradually. You'd be surprised how many times soak testing shows you that your systems are not really resilient. Of course, we all know about security testing, and they are extremely important when it comes from a resiliency point of view. We just saw a few examples of the kinds of things that can break. Finally, these days, no system can claim that it's resilient without good monitoring, without meaningful alerts, having access to logs, metrics, traces, and ability to detect anomalies early. Without observability, you're flying blind. Now, resiliency testing is a huge space, and I obviously cannot cover all of this in one video. But I do want to go deeper into two areas that are both critical and massively underaddressed: the whole negative functional API testing and service dependency testing. And I'll show you how you can use API contracts to automate both of these in a much smarter, faster, and more reliable way. So let's dive in. Let's look at a simple example application and see how we can test the resiliency of one of its service. We have an application that sends a request to an order BFF, a backend for front-end service. The BFF then calls an order API, gets the order details, And then after that, it publishes certain events onto a Kafka topic so that an analytics service can process them. Finally, the BFF returns the response back to the application. Even though this architecture looks straightforward, a lot can go wrong in this flow. And our goal is to test the resiliency of this BFF service because that's the service that's sitting right at the boundary and coordinating all these calls. So, to do this effectively, we want to test the BFF in isolation without involving real application or real downstream systems. So instead of invoking the application, the BFF through an actual front end, we'll simulate incoming requests from a API test. And instead of calling the real order API or a Kafka broker, we'll stub out these dependencies. This lets us simulate bad payloads, inject faults, slow down responses, or trigger retries and fallback options, all without disturbing a real environment. This gives us complete control over the dependencies and how they behave, so we can see how the BFF reacts under different failure situations and verify whether it's truly resilient. With that, let's jump into a quick live demo. As you can see, I have the order API and the order BFF already running. So let me quickly jump now into Specmatic Studio. So here in Specmatic Studio, first thing we will do is we will start the dependency, which is Kafka. So we are dependent on a Kafka topic. We're going to just run this as a mock, so we don't need to have an actual Kafka broker running. Next, let me bring up the specification of the BFF. So this is the specification of the BFF. This is the OpenAPI specification. Here's just a simpler view of the specification. We have several endpoints. So if I go here and this is running as you saw on port 8080. So I'm just going to go ahead and run the contract test. And you'd see it's run a bunch of contract tests for us, and it's some of them have failed. So for now, I want to just remove some of these failures. We will deal with them when in a later point. Okay, with that, let me quickly rerun the tests. And great, we see that we have 12 tests that were generated for /products post method with 201 response code. Let me quickly click here and you would see a quick explanation of what each of these are doing. If you expand this, it says, okay, I'm basically making a post request to /products. And it basically contains all the key. There's an enum for which I've set the value book, and the inventory is set to a value within the specified bounds. So what Specmatic has done is it's basically generated a contract valid request, and it's sent it to the order BFF, which in turn has returned back this response. Right, so this is the first test. What you will see is it did generate a whole bunch of combinations. In this case, you'd see that it took book, here it took food, it took gadget, it took others, so forth. So these are basically iterating through all the enum values. Right, this is very basic happy path schema validation, if you will. Now let's turn these examples into something that we want to specifically control so that we don't generate all these combinations. So let me quickly go here to the examples, and I'm going to go ahead and generate an example for us. So what we're basically telling Specmatic is that use this specific payload and expect a response of this structure back. And so that's good. Of course, here, if I were to make any mistakes, that is going to cause a problem. So if I were to make this 5, for example, and save and validate, so then Specmatic says, hey, as per the contract, this should have been a number, but you're sending a string instead. All right. We, of course, have this handy quick fix, which can automatically fix these kinds of errors for us. So this looks good. Let's go back. Now let's also generate a example for the get find available products. So here we are saying find all food items, and then it's returning a food item back to us. So that's good. And finally, let's do one for the post request on the orders. So with that, we have three examples that we have provided to Specmatic. Let's rerun these contract tests, and now you'd see it is specifically using only the payload that we have provided to send the request, and then it gets a response and validates it. So this is great, right? This is controlling exactly what data we want to send. But one disadvantage of this approach, as you saw earlier, we had 12 tests over here. Now that is reduced to one. But that's not a problem because Specmatic has a built-in feature that's called the generative tests, or what we call as the schema resiliency test. So if I turn that on and I quickly run these, what you would see is Specmatic now has gone and generated a whole bunch of tests. And in this case, not just originally the small number of tests that we were generating, but a much larger number. So these 12 we've already seen, these are all the positive scenarios that is kind of quickly called out here, where we are providing all valid values and we are expecting a 200 response back, or 201 response back in this case. But what is interesting is Specmatic also generated 130 tests where what it's tried to do is it's tried to send a malformed request to the BFF, and it's expecting that the BFF can handle that gracefully and give us a 4xx response back. So let's look at this particular request where we are saying that I did a post on /products. I took this basic example that you've provided, but I mutated that, right? So I took all the keys and I mutated basically string to null for the field name, right? So you'd see here name is set to null, and we do expect a 400 bad requests, which our service of course is doing the validation and returning that. And it's clearly saying that name must not be null. So this is good. This shows us that our service can handle these kinds of malformed requests, and it's gracefully handling those. You'd see there's obviously enums, and we're iterating through those different values like before. But also you would see that sometimes we try and set the value out of bound and see what is happening in that case. Let me find an example of an out of bound example. So here is an example where you would see that what we are trying to do is we are trying to set a value greater than the maximum. So the maximum allowed is 101, and we've set the inventory to 102, and we do expect a inventory must be less than 101, right? And so here, instead of someone trying to do all these boundary case analysis, we are using the power of Specmatic to generate all these tests for us. And that saves a lot of time for the engineers, makes it much more exhaustive in terms of testing all these boundary case analysis. So this is great, right? So we've had now all these tests generated, we have these things working, that's great. Now that we have this working, what we want to do is we've excluded this 429, right, which is basically too many requests. So sometimes what might happen is you might hit your service might get a lot of requests, and in this particular case the BFF is dependent on the order API to return the response back. And what if the order API is also overwhelmed and it cannot respond back in time? Then you would want to do an active load shedding, which is essentially an equivalent of a 429, where you would basically drop certain requests and say, hey, retry after some time. So let us see how we would be able to simulate an example for that. So first of all, let's give an example for the 429 case, right? So I've just generated an example. Let's look at it. Here, I would want to say when the type is other, for example, and let's say the page size is 20, then I would like to see a 429 and let's say retry after 2 seconds. So this is giving an example saying whenever this payload is sent, I would expect to see a 429 response back. So with that example in, And for now, I'm going to just turn off generative tests and I'm going to include this 429 example. So with that, let's quickly run the test. And sure, as expected, this particular test will fail because here we are expecting 429, but the actual service is returning a 200 immediately because the downstream service that we are dependent on is right now not overwhelmed, right? And it is giving a response immediately, which means the BFF is responding immediately. So, how can I simulate the downstream service being overwhelmed? One way to do that is, let's say we simulate that the downstream service is not going to respond back within the timeout period, and that would cause this to time out. And let's say our logic is if the downstream service times out, let's say for few subsequent times, then we want to start returning a 429. So that's great, but how do I tell the downstream service that on this particular request, time out while for the rest of the cases work as expected? That's a little trickier to do with an actual service. So the first step of this, what I'm going to do is I'm going to get rid of the actual service and service virtualize that. So to be able to do that, we're going to use another feature of a proxy recording where we'll record the traffic, service virtualize the service, and then basically use a mock to do all these fault simulations for us. So for now, I'm just going to go ahead and again exclude this for the time being. Let's just make sure that we have all running tests. And at this stage, we would be able to go ahead and record the interaction with this service. So let me click here. And our order API is running on port 8090 at order API. What we want to do is we want to run a proxy on port 9090. So let me start the proxy. But however, the order BFF is hitting this on order API 8080. So let's quickly jump to our configuration here. And as you can see, order BFF is talking to the order API on 8090. So I'm going to change that to talk to Studio instead, which is where our proxy is running on port 9090. So with that change, let me just do a Docker compose up, and that would just recreate this particular service. So with that change, if I go back and run my tests, perfect. So it is actually making the request to the proxy, and we can go here and see the proxy did get, a bunch of these requests. We can expand and see what was the request it got, what response it gave. So perfect. We have recorded the traffic. Now when I stop the proxy, what it's going to do is it's going to generate a specification for me. So this is the OpenAPI specification for what we just recorded. And it's also recorded the examples that were going through this service. And so this allows us now to basically simply switch to the mock tab here. And on port 9090, I should be able to run this particular mock server. Now that I have this mock server running, I don't really need this service anymore. So let me stop the order API because we don't need that anymore. And let's see if our tests continue to pass. Of course they should, but let's verify that. And sure enough, you'd see now it's hitting, and we can go here and go to this mock, and you see these one requests have come through. So that's great. All right. Now, let's also turn generative tests on and run these tests. Some of them will fail, and we will see why, and we can then go ahead and fix them. So as soon as I run these tests, you'd see that 4 of these tests have failed. And the reason they have failed is essentially we are sending in the request parameter, we are sending book, for example. However, we've only recorded one example, which is with food. So right now our mock only knows how to respond to food, and for others it does not know how to respond. So it's generating contract valid, however random values. So one way to fix that is pretty easy. So let's quickly go here. You'll see that like couple of them were served from the examples, but rest of them Specmatic just generated contract valid values, and these may not really work, right? So let's go ahead and fix the example for get. So what we have here is we are saying whenever it matches this particular food and this date, then respond back with this kind of a request, and it's like obviously ton of them. So let's simplify this a little bit. I'm just going to keep maybe 2 objects in the response. And the main problem here is that we have a type which is hard coded to food. Let's make that generic. So what I can tell Specmatic is match this type, and it should be of type string. And whenever you get this in the response, make sure that you send the same type back, right? So we're going to use this function and just say return this type back. What we also want to do is we don't really care about specific dates, so we can just say, hey, any date, as long as it matches any date, I'm okay. Just accept that, match that with this request. Same thing with page size. We actually don't really, want to hard code that to 10. So we say any number, if it comes, you can accept. We also need to make sure we change that over here. And so with that, let's quickly save and validate that example. The mock would have automatically reloaded itself. So let us go now to the tests and rerun all our tests. And this time you would expect all the tests to pass. Perfect. So we have now an exactly identical mock, which is Service Virtualize, our actual service that was running. We don't need that anymore. So now we can basically include this 429 and go ahead and simulate that. I'll again turn off generative. We just want to focus on this particular guy. So let me quickly run that. And sure, this is still failing because we were expecting a 429, but we're getting 200. But now, because we have a mock running, we have a lot more control over it. So we should be able to go to the mock and say, hey, anytime you get requests at 200, but not any requests, right? Because here we are handling any type. And now what we'll do is we'll put in a special condition which will basically say, so I'm generating an example, and this will say when the type is other, right? Whenever the type is other, we want to do something. Again, we don't really care about the date, so I'm just going to make that common date. Page size, we want to specifically say whenever the page size is 20, there is no body in this case, and we want you to respond back with whatever you were responding. This is fine. However, we want to do 2 important changes. The first thing is we want to set a transient expectation. What does a transient expectation do for us? A transient expectation essentially says that this response should only be served once, right? It's transient. So whenever a request, incoming request matches this payload, then return this response, but return it only once. And after that, this is no longer valid. Also, what we want to do, if you remember, is we want to simulate a delay, right? So we want to say delay in seconds. So we want to simulate a delay, and let's say we put a delay of 2 seconds because our service times out after 1 second. So with that, let me quickly save this and validate. And so what we expect now to see is whenever the request is matching this particular thing will kick in, it'll delay the response. By that time, our service should time out and it should return a 429. Then subsequently, when a request comes again, because this is transient, this will no longer be active, and it will fall back to our first example, which we have here, which matches any, and it will immediately respond back, right? So with that, let's quickly go and rerun our tests here. And you see it's taking a little bit of time because this is waiting for the timeout. Perfect. So this test has now passed. Let's see what happened here. So the first time we made a request for type other, with certain dates and page size of 20, and that did cause a 2-second delay, which resulted in a timeout, and then that resulted the BFF to return a 429 back. And then Specmatic will retry after, basically because we are saying retry after 2 seconds. So the Specmatic will again retry the same request after 2 seconds. And because it was a transient expectation, the next time it won't kick in. And now we've got a 200 response back. So that quickly shows us how we can use this mock to simulate delays, and then that allows us to test too many requests kind of scenarios. So that's great. Now let's do the same for 202, right? So for those of you familiar with 202, we are saying when we do a post request, and if the downstream services where we are actually basically creating the product, if that downstream service cannot respond back in enough time, then we cannot immediately respond back with an ID of the product and a 201 response. So instead, what we will do is we will kind of switch to an asynchronous response, in the sense that we're going to return a 202 response back, which is a partial accept, and we will give a link to another endpoint where you can get the actual data whenever it's available, whenever the product is created. So let me go ahead and include this, and let's also like we did last time, let's also generate an example. So we're going to say, hey, whenever I do a post, and in this case whenever I do a post for this particular request, right? And so we will say a sync request, right? That's whenever we make a request for a sync request, and let's say this is food and 5, that's fine. Then we expect a true or true response back. And in this case, we're using a monitor pattern. So it will return a link to a monitor, which then will actually be queried to get the details of the created product. And so this async request is essentially the name of the product. Whenever that comes, we are saying, hey, simulate a delay. So that will allow us to see if the 202 is working as expected. So with that, let me quickly save and validate. Okay, perfect. So that's working fine. Now let me go ahead and run the test. And you would see that, of course, the 429 has also failed because the mock that we had a transient expectation. So let me quickly go to this mock, stop it. This will clear out everything and rerun this. And now let me run the contract test again. So this time we should see the 429 work, yes, as expected. However, the 202 has failed. Let's understand what happened here. So we were expecting a 202 response, but we actually got a 201 response. What this means is our mock is immediately responding back, and so we are returning with a 201 response instead of a 202. So let's go ahead and basically add a delay in our mock. Now what we want to do is we want to generate another example, and here what we are saying is whenever the name, remember that we said that name has to be unique. So whenever the name is a sync request, which is the name of this, and type, basically we want to be able to cater to any type. We don't want to hard code this, right? And this is where we have a little bit of a special syntax, and it's called a match function. And in the match function, we say, hey, the data type of this particular thing should be string. The value, you can get different values because this is an enum. So match each of the values, but match them exactly one time. So that's this times 1. So what we are saying is this is a match function which will be used to match a request. And similarly for inventory, because we will get the min, max, and a value in between, we want to do something similar for inventory as well. Right, so we're basically saying anytime the name is a sync request, but match any of these values exactly once. So great, this is fine, but we need to add again a transient because we want this to only be valid for one combination of this request, and we want to delay, we want to add a delay in seconds, and we want to say 2. Okay, let me quickly validate this. That looks good. Let me come back. This would have restarted our mock, but anyway, I'm just going to clean this out so it's easy for us to see what's happened. And now let's go back and rerun all these tests. Okay, all of these have worked, but this is still failed. So this is still returning a 201. Let's see, did we make a mistake here? So in case of post, both of them have responded immediately. Oh, I forgot to deal with this idempotency key. So let me quickly go back and show you what I mean by that. So this is the transient, and also I had a typo over here. Transient expectation, but this idempotency key is going to be unique, so we don't really care as long as it's a string, right? So let me set that, and I've got the transient now correct. So let me save this. Again, I'm just going to quickly stop the mock server. That should clear everything out. And let me now go back here and rerun all of these. Okay, perfect. So you see now all of these are working. So we did have a 202. Let's quickly understand what happened here. So we made a request to /products. Remember this async request. We send that food in 5, and this downstream service did not respond back in time. So the BFF came back with a 202 and gave us a link to the monitor. The next time we hit the monitor, and the monitor in turn basically invokes that service, and this time it did respond back with a successful response and the details that we expected. So that's another example of how we can test a 202 situation. Now, of course, we've tested for one specific examples, but what happens if we turn generative test on and run everything? So first, let me quickly recycle the mock. Let's clear this. And now if I come back here, I turn generative test on and let me run this, right? So that test went very quickly. Now you see the 202 ones. There's a combination of these that Specmatic is going to generate. Each one is going to take roughly 2 to 3 seconds because of the timeout and then the retry on the monitor. And it's going to cycle through all the combinations of the different types. The enum has 4 types of enums that it supports. And also the inventory has a min and max constraint. So it's going to try and circle through all of those and make sure for all of them 202 is being handled correctly. So there you see 12 combinations again got exercised. And with that, you see we have 180 tests that are all passing. So similarly, we can now also enable this 202 and kind of repeat the same process. But I hope you understand like how we have been able to, first of all, record the traffic, service virtualize that, convert it into a mock for the dependency, and then use intelligent ways of basically injecting delays, which allows us to exercise scenarios like 429 and 202 and so forth. And all of this without writing a single line of code. So this is kind of like the whole intelligent mocking and intelligent service virtualization for you. So quickly to wrap up then, so what we are saying is that in today's world, resiliency testing is no longer an optional thing, right? It is something that is the APIs have become the fabric of the business systems. Failure is not an if, but a when, right? And you need to safeguard against that. And the key point that we've tried to demonstrate here is how you can shift left the resiliency testing of your services, again, using Specmatic's no-code approach. I hope that made sense, and please feel free to reach out to us if you have any questions. Thank you.